In this video, I'm going to solve a problem that involves application of exponential functions. So basically, this is what it is. If interest is compounded continuously, okay, at 7% per year, then how long does it take to double your money? So to solve this problem, we kind of have to start off with the formula for compound interest, where interest is compounded continuously. So let's say A of t represents the amount of money in an account after t years. That must be equal to A sub 0 or A naught times e to the power r t, where r is the interest rate and t is the time in years. A naught is the initial amount invested. So that's the formula. Now, please do keep in mind, this formula is true only for compounding that is continuously. That means continuous compounding. Now, the problem is asking you, how long is it going to take to double your money? Okay, so one of the things that students get a bit confused, so how much money I need to invest? Actually, it doesn't matter how much you invest. If everything else is the same, you can invest $1. How long is it going to take to double your money to become $2? On the other hand, if you invest $100, how long is it going to take to double your money? That means to get $200. If you invest $1 million, how long does it take to double to get to 2 millions? So it doesn't matter really. So in this case, our initial investment is A sub 0 or A naught. So we want to double it. So we want to double it. That means this A of t is going to be 2 times A sub 0. If I had $5 here, it would be 2 times 5 on the left, 10. If I had $10 here, it would be 2 times 10, 20. So you get the idea. So whatever money I invest, in my case it is A sub 0, whatever number it is, I want to double it. So you multiply it by 2, must be equal to A sub 0 times e to the power rt. Okay. Now, r is given to be 7%. Okay. So 7%, if you express it in decimal, you have to express it in decimal, is going to be 0.07. So it's going to be 2 A sub 0 is equal to A sub 0 times e to the power 0.07 times t. Now I can divide both sides of this equation by A sub 0 to get rid of the A sub 0, right? This and this cancel out, that gives me 2 is equal to this cancel out, e to the power 0.07 times t. Now I need to solve for t. Remember, to solve for t, we need to apply the inverse of e to both sides of this equation so that we can get rid of this base e. So that is to say, we apply ln, natural log. Inverse of e is ln, exponential function is ln. So it's going to be ln of 2 is equal to ln of e to the power 0.07 times t, or ln of 2 is equal to, this is an exponent, so I can pull it in front. So it's going to be 0.07 times t times ln of e. Remember, in going from here to here, I have used this fact, ln of a to the power m is equal to m times ln of a. So that's the rule I have used. Now ln of e, by the way, is just 1. So that gives me ln of 2 is equal to 0.07 times t. Or t, if I divide both sides by 0.07, is going to be ln of 2 divided by 0.07. By the way, ln of 2 is a very special value. You can approximate. So I'm going to put an approximate equal sign. Is 0.69. Okay. Divided by 0.07, which approximately comes out to be about 9.9 years or around there. So which is approximately about 10 years. So this is called 7-10 rule in sort of like finance. If you have an investment that returns 7%, it takes about 10 years to double your money. On the other hand, if the investment return is, let's say, 10%, okay, investment return is 10% instead of 7%, that it will take about 7 years to double your money. So to double your money, 7% interest is going to give you 10 years to double, and 10% interest is going to give you 7 years to double. So that means at 7% interest rate, continuous compounding of course, it takes roughly about 10 years to double your money. But on the other hand, if your continuous compounding or return on investment is about 10%, then it takes about 7 years to double your money. So this is how you solve these types of problems. I hope that this discussion was helpful. Thank you very much.